So now that we have a little information on this problem, let's go ahead and actually establish the two sample difference in means. Let's go ahead and just actually establish and build that, all right? So when we talk about a sampling distribution of the difference in mean, the parameter here, the parameter that we're interested in is going to be the population mean, or the sampling distribution of the population mean, which we'll call mu of A minus mu of B. And this stands for the true mean difference. The true mean difference between mu of A and mu of B. And the standard deviation for this, or A, sigma A minus B, is equal to the standard deviation for A, and we square it, divided by the sample size of A, plus the standard deviation of B, and we square it, divided by N of B. Now, when we look at the sampling distribution, though, the sampling distribution is going to look at x bar of A minus x bar of B. And it'll follow a normal distribution with mean, mu of A minus mu of B, and standard deviation, square root of, again, sigma A squared plus sigma B squared. Both of these, N of A divided by N of B. So we want to be able to show this through the statistics right here, that this value right here, this is the sampling distribution, that this value right here is normal with the mean that's equal to the population difference and the standard deviation equal to this right here. In order to do that, we have to go through conditions. And we have three conditions that we need to check. The first condition is that each sample must be randomly chosen from the population. Generally, that'll be stated. We can also assume that they're randomly choosing things from the population. The next condition is the independence condition. And remember, our independence condition is what we also call our 10% rule. So you can't sample more than 10% of either population. Also now, we need to show that the populations, or state that the populations are, here's the big new thing, that we need to state that each one is independent. And then our last condition that has to be met is going to be our normality condition. And we need it to be normal again because we always want to use this normal curve to show our probabilities. Since we're talking about means, we show normality through the central limit theorem if we can. And what I mean by that is we're going to try to show that our sample size is large enough. So that's a large enough condition. And we need to have a sample size for each population, for each sample that we're taking needs to be greater than or equal to 30. So the next thing we're going to do is we're actually going to try to work out this problem. We're going to go through this problem and work it out, all right? So remember our process for solving any type of problem like this is we have a 4-step process. Our first step that we're going to do is we want to define the parameter. So we're going to define our parameter here. And our parameter in this case is mu of A, which is actually equal to the true mean wait time. This is the true mean wait time for passengers in level A. And then we have also mu of B, which is the exact same thing except for B. And then what we're going to define now is this new parameter, which we're going to call mu of A minus mu of B. And this new thing is going to be called the true mean difference. The true mean difference between mu of A and mu of B. And we're going to calculate that value now as well. Or we'll calculate that. So the first thing is to define the parameter. The next step, once we have the parameter defined, we're going to state our conditions. And when we state our conditions, remember, the first condition is our random condition. So we want to make sure that both samples were chosen randomly. And if you come up here, it tells me that they took separate random samples. So because this stated already, we're good on the random condition part. We have that stated in our problem. The second thing is that it is independent. And remember, we showed that through the 10% rule for both. So we write that as surely. Our sample size here is 100 people from each level. So surely 100 people is less than 10% of all people on each level. And then the other thing we need to show is that the samples are independent of each other. And because we took separate samples, level A is independent of level B. And the last thing I want to show is the normality here. And to show the normality, I'm going to use the sample size. So because you took 100 for each one, because 100 is bigger than 30, or n greater than or equal to 30, by CLT, we need to define the parameter next. So we're going to say, by CLT, the distribution is approximately normal. The third thing, you need to state the actual parameter. So in step one, we define the parameter. Here we're going to state the parameter. And remember, our parameter here is x bar A minus x bar B. That is the parameter for the sample. Follows a normal distribution with a mean equal to the difference between the two populations. This should be 24.5. So mu of A mean was, mu of A was equal to 26. Mu of B was equal to 24.5. If I want to find the difference between those two, 26 minus 24.5, it's just 1.5. 1.5, and then it has a standard deviation of the square root, or take A value, take the A standard deviation, which was 7.57 squared, and divided by the N, which is 100, plus the B, which was 4 squared, divided by the N, which is 100. And when I do this, calculate this value here, I'm going to get 0.856. Now, the reason we needed that is because we want to show that it was normal. Now that we know that it's normal, your fourth step is to find a probability. Find a probability. And the question was, what is the probability that the mean wait time for A will be less than B? Remember, we already defined that, so the probability that the mean wait time for A, which was, we want to find the mean wait time for A, so x bar of A will be less than x bar of B. In this case, that's x bar A. The differences will be negative, less than 0. So we're going to draw a normal curve. On my normal curve, I'm going to put the mean of the population. Well, the mean of the population is sitting here at 1.5. And I'm asking you for a difference of 0 to the left of 0. So 0 sits on this side somewhere. When it goes to the left of it, that's this right here. And because this is a normal curve, we can do normal CDF. Normal CDF. And we have our lower bound. In this case, our shading is going to start out here at negative 999. It's going to stop at this value of 0. Our mean is 1.5. And our standard deviation is this value that we calculated, 0.856. So when I put this in my calculator, remember I go menu 6, 5, 2. When I put in things there, the bound, the lower bound, the upper bound, the mean and standard deviation, I get 0.04. 0.0396, I think, but it's 0.04 when we round up.